Today we are going to learn about detecting model drift with statistical tests. We'll explore how to effectively use statistical tests to monitor and detect model drift, ensuring the accuracy and reliability of predictive models.
Welcome to our video on detecting model drift with statistical tests. Model drift occurs when the statistical properties of your target variable change over time, affecting the predictive power of your model. This drift can lead to inaccurate predictions, impacting business decisions and operational efficiency. Detecting and addressing model drift is crucial for maintaining the reliability of your models, particularly in dynamic environments. In this video, we'll explore how statistical tests can be used to detect model drift effectively, ensuring your models remain accurate and trustworthy.
Model drift can be broadly categorized into two types: data drift and concept drift. Data drift occurs when the input data distribution changes, while concept drift refers to changes in the relationship between input data and target variables. Real-world examples include seasonal changes affecting sales forecasts or changes in consumer behavior altering demand predictions. Undetected drift can lead to poor decision-making, financial losses, and diminished trust in AI systems. To counter this, continuous monitoring and adaptive strategies are essential. By understanding these implications, you can better prepare to address drift in your models. Several statistical tests are commonly used to detect model drift. The chi-square test is useful for categorical data, comparing expected versus observed frequencies. The Kolmogorov-Smirnov test is a non-parametric test that compares two distributions, ideal for continuous data. The Kramer-von Mises test is another non-parametric option, providing a goodness of fit test for distributional changes. Jensen-Shannon divergence measures the similarity between two probability distributions, offering insights into drift magnitude. Selecting the right test depends on your data type and the specific drift characteristics you are monitoring. Choosing the right statistical test for detecting model drift requires a clear understanding of your data type and distribution. For categorical data, tests like chi-square are appropriate, while for continuous data, non-parametric tests such as Kolmogorov-Smirnov are preferred. Consider the assumptions each test makes about data distribution and evaluate their sensitivity and specificity to detect drift accurately. Match the test to the type of drift you expect, balancing the complexity of the test with how easily you can interpret its results. This careful selection ensures effective monitoring and timely detection of drift.
Implementing a statistical test to detect model drift involves several key steps. Start by defining your hypotheses. The null hypothesis assumes no drift, while the alternative suggests drift is present. Next, collect and prepare the data you need, ensuring it is relevant and representative. Perform the chosen statistical test, applying it to compare current data with historical or baseline data. Analyze the test results, looking for evidence of drift. Finally, implement necessary changes to your model or data processes based on these findings, ensuring your models remain accurate and effective. Interpreting the results of a statistical test is crucial for taking actionable steps. Start by understanding the test statistics and determining the significance level, usually set at a 5% threshold. A significant result indicates potential drift. Assess the impact of this drift on your model's performance and accuracy. Plan corrective actions, such as model retraining or data preprocessing, to mitigate the drift's effects. Communicate your findings clearly to stakeholders, explaining the implications and proposed solutions. This ensures informed decision-making and continuous improvement of your predictive models.
Let's explore some real-world examples of model drift detection. In e-commerce, sales forecasting models need to adjust for seasonal trends and changing consumer preferences. Financial institutions monitor risk models for shifts in market dynamics and regulatory changes. In healthcare, diagnostic models may require updates as new medical research emerges. Consumer behavior analysis often reveals drift due to evolving social trends. Each of these scenarios highlights the importance of timely drift detection and adaptation. By learning from these examples, you can enhance your strategies for maintaining robust and reliable models in your domain.
Automating drift detection offers significant benefits, such as increased efficiency and reduced human error. Various tools and frameworks, like TensorFlow Data Validation and River, provide built-in capabilities for automated monitoring. Integrate these tools into your data workflows to ensure continuous model evaluation. Set up alert systems to notify you of significant drift, allowing for prompt intervention. While automation streamlines the process, challenges include handling false positives and ensuring system scalability. Address these by customizing thresholds and maintaining robust data pipelines. Automation empowers you to maintain high-performing models with minimal manual intervention.
Adopting best practices in statistical drift detection helps maintain accurate models. Regularly update and retrain models to incorporate new patterns and trends. Ensure data quality by addressing missing values and outliers, which can skew test results. Avoid overfitting statistical tests by selecting appropriate significance levels and validating assumptions. Balance detection sensitivity to minimize false positives without missing significant drift. Document your processes, including test selection, implementation, and interpretation, to ensure transparency and continuous improvement. By following these practices, you can effectively monitor and address model drift in your predictive systems. In conclusion, detecting model drift with statistical tests is essential for maintaining the accuracy and reliability of predictive models. We've explored various tests, implementation steps, and their applications in real-world scenarios. By understanding and applying these techniques, you can ensure your models remain effective in dynamic environments. Continuous improvement and automation are key to successful drift management. We encourage you to apply this knowledge to your own models, enhancing their performance and impact. Thank you for watching, and we hope you found this video informative and valuable.